I'm Lexi, and I'll be going over hypothesis testing and two of the kinds of testing. So first we can go over hypothesis tests concerning a single mean. So often we want to establish a significant effect about some scientific system. For example, a medical researcher may decide on the basis of experimental evidence whether drinking coffee increases the risk of cancer. So, a statistical hypothesis is an assertion or a conjecture concerning one or more populations. And so, if we reject the hypothesis, that means that we have enough evidence that refutes our hypothesis. So, the structure of how we make our hypotheses are that we have our null hypothesis, which is basically what we're trying to disprove, and that's represented using H0. And then we have our alternate hypothesis, which is HA or H1, and that is basically the opposite, or it basically opposes our null hypothesis. So, for example, if our null hypothesis is that the probability of something is 0.5, our alternate hypothesis could be that the probability is not 0.5, or that it's less than 0.5, or that it's greater than 0.5. So at the end of our hypothesis testing, we can either reject our null hypothesis in favor of our alternate hypothesis because we have sufficient evidence, or we can fail to reject our null hypothesis because we don't have enough evidence. And we will make sure we will be only rejecting or failing to reject because we can't actually accept the hypothesis since we're only disproving it or just not being able to disprove it, but it doesn't mean that we can accept it. So an example here is that suppose an engineer is interested in the fraction defective P in a certain manufacturing process, and so she thinks that P equals 0.1, where P is the fraction of defectives, and so here our null hypothesis would be P equals 0.1. And then our alternate hypothesis is P is not equal to 0.1. But we could also have our alternate hypothesis be P is greater than 0.1 or P is less than 0.1, depending on what we're looking for. So hypothesis testing is generally conducted with these steps. So we state our null and alternate hypotheses. We choose and calculate our appropriate test statistic, compute the rejection region, which is the p-value, and then based on our significance level, we decide whether or not to reject our null hypothesis. So this basically means that we're performing our test assuming that the null hypothesis is true, and basically we're trying to find the probability that our result could happen under the null hypothesis. So for example, if you flip a coin 50 times and it lands on heads every time, it's possible that you got really lucky and the universe decided that you wanted to land on heads. But more likely than not, the coin is probably not a fair coin. And if the probability of it happening by chance is small enough, which means it's less than our significance level alpha, then we reject the null hypothesis. Otherwise, we fail to reject, but we don't accept it because we've only proved that we have enough evidence to reject it. Or we don't have enough evidence to reject it. So we have two different types of errors, type 1 and type 2. And so type 1 errors are the rejection of the null hypothesis when it shouldn't be rejected, when the null hypothesis is true. And this is called a type 1 error, so this is like a false positive. And then our type 2 error is failing to reject the null hypothesis when it's false, and that's called a type 2 error, and that is known as a false negative. So we have our table here. You might want to remember this and write it down in your notes. So here are where we have our type 1 and type 2 errors. So if H0 is true and our null hypothesis and we fail to reject, then we made the right choice. But if it's true and we rejected it, we get our type 1 error. And if it's false and we fail to reject, we get our type 2 error. And if it's false and we reject it, then we get the correct decision. And so our type 1 error is denoted by alpha, so that's our significance level. And if we want to reduce the chance of getting a type 1 error, we can lower our significance level, and that will decrease our chance of getting a type 1 error. And then our type 2 error is denoted by beta sometimes. In common philosophy, we want to control our type 1 error, so we can do this by just making our significance value alpha smaller. So oftentimes we'll get 5%, sometimes we'll get 1%, sometimes we'll get 10%, but usually we want to make it really small just so that we reduce the chance of getting a type 1 error. So our p-value of a hypothesis test is the probability of observing the specific value of the test statistic or a more extreme value under the null hypothesis. And the direction of the extreme value is indicated by the alternate hypothesis. So this is basically the probability that what the null hypothesis is true, but we just got an extreme value by complete chance. And so we want to make sure that our p-value is really small if we reject it, because if the chance is really small, then it's less likely, the null hypothesis is less likely to be true. So after predetermining our value for our type 1 error, so our alpha, we can reject our p-value, we can reject our null hypothesis if our p-value is less than our significance value alpha. And then otherwise we fail to reject. And then this isn't always our final decision, because if our p-value is really close to our alpha, we might need to further analyze.